motion of a motorcyclist in death well, and we have to find the expression of minimum height from which a motorcyclist looping in a vertical loop in a globe should start to roll down and go round the loop. Minimum height from which a motorcyclist looping in a vertical loop in a globe should start to roll down and go round the trip. We consider AB as an inclined plane, and a motorcyclist of mass M starts to roll down from the point A of the highest point of the inclined plane with the initial velocity u equals 0. Initially, the motorcyclist at the point A on the inclined plane was at 0, and we can consider a vertical loop at the point B. Around which the motorcyclist will travel. This is the vertical loop. Or well of death or death well. This is a vertical loop which has the radius small r, and after rolling down the inclined plane, the motorcyclist will reach to the point B, and at the point B of the vertical loop, the motorcyclist will have the velocity v2 equal root over 5 gr, where r is the radius of the vertical loop. This is the vertical loop along which the motorcyclist will move without sliding. This is the vertical loop of radius r, and at the lowest point of the vertical loop B, the motorcyclist will have the tangential velocity v2 equal root over 5 gr, and the motorcyclist will loop the vertical globe anti-clockwise as shown in the figure. To acquire the minimum velocity under bracket v2 equal root over 5 gr, to acquire the minimum velocity under bracket v2 equal root over 5 gr at the lowest point B of the vertical loop, or globe of radius r, the motion of the motorcyclist has to roll down. The motorcyclist has to roll down from the highest point A of the inclined plane at the vertical height h. The motorcyclist has to roll down from the point A at the vertical height h. Now the motorcyclist starts to roll down the inclined plane from rest, and it reaches to the lowest point B of the vertical loop. It has the tangential velocity at the lowest point B as v2 equal root over 5 gr, and the motorcyclist will able to move along the vertical loop. Using the principle of conservation of energy. Between the 2 points A and B, along the inclined plane, we get half m u square plus mg ha is equal to half m v2 square plus mg lb, or half m into 0 plus mgh is equal to half m v2 square plus mg into 0, or mgh is equal half m v2 square, or gh is equal half v2 square, where v2 is equal to root over 5 gr, which is the minimum velocity of the motorcyclist at the lowest point B of the vertical loop, or the well of death gh, and finally we get gh as equal v square by 2. gs as equal v square by 2, where v2 is equal root over 5gr, or comma gh is equal half into 5gr, and we get height h from which the motorcyclist will start to move. That will be h, which is 5 by 2 r. Therefore h is equal to 5 by 2 r, which is the height from which a motorcyclist should start to roll down to complete a vertical loop of radius r. To complete, h is equal to 5 by 2 r, which is the height from which a motorcyclist should start to roll down to complete a vertical loop of radius r.